Time to spend a little bit of time with EIGRP and route redistribution. This lab should look very familiar to you. Routers 1, 2, and 3 are in a RIP version 2 domain, same as with the last lab. As a matter of fact, everything is the same as the last lab as far as the addressing goes. The only real difference, of course, routers 2, 3, 4, and 5 have an EIGRP AS100 adjacency going on instead of an OSPF adjacency. Any extra commands, any extra labs, any extra networks that were added, they're all gone. The only networks here are 10.1.1.1.0/24, 172.12.123.0.24, and then 30.110.24 in the EIGRP AS. Now, EIGRP does require a seed metric as well, and it's just a tad more complex than RIPS, as you might guess. And we can do this or bring the seed metric into play in one of two ways. You can add it to the redistribute command itself at the very end, or you could use the default metric command. Now we're going to use the redistribute command method, but I'll show you the default metric options here on the live equipment in just a moment. As we get ready to get started though, of course, what's the first thing we want to do? Let's make sure our ASBR to be has the route in its routing table. That's going to be router 3 again. We're going to do the exact same thing we did last time. And there's the route in question, and the EIGRP table right now is empty. We are going to spend time with router 2 and seeing what changes, if any, happen in router 2's routing table, since router 2 is also a border router between our RIP and EIGRP domains. We'll also check out the tables on 4 and 5. I know in OSPF lab we might not even have looked at those, but I promise you we'll look at them here for a few minutes in this lab. Now let's go ahead and get our redistribution started. I'll show you the default metric command, and there it is, default metric, set metric of redistributed routes. It's the sixth one down. And if we chose this method, you would then have to put in your bandwidth value, then your delay value, and I'm kind of pulling these out of the sky, 255 for total reliability. I'm going to put 1 for that one, and then 1500 for the MTU metric. And after that, I believe you can put, yep, that's it. Default metric, the 5 values, that's it. Knowing the order of those is probably a good idea. But when you do this, this would be applied, of course, to all of your routes redistributed into EIGRP that did not have specific ones put on. That's exactly what we're going to do now, is apply a specific metric, seed metric, to a specific set of routes being redistributed, in this case only one, that being our RIP route. So let's do that. It's redistribute, and pretty much the same choices as we have with OSPF, including connected and static. And we've got to put a metric, so that's what we're going to do now. And you'll notice that bandwidth, delay, reliability, then load, and then MTU. Now you can put a route map reference on the very, very, very end of all of this, but we are not going to do that. We're going to stop right there, because frankly, I think that's enough. So let's go ahead and hit enter, and then we'll start checking some tables. Let's go down to router 4. I'm going to check out routers 4 and 5. And they see both routes we expect them to see. It sees the 10.1.1.0 network and also the RIP-enabled 172.12.123.0 network also coming in from router 3. 5 is going to have the exact same table, I hope, after saying that. Exact same table. And a couple of things here to note, of course. The first being DEX. That is your routing table code for a route learned by EIGRP via route redistribution, that making it an EIGRP external route. The other big difference is the administrative distance difference, because with OSPF, and we saw all kinds of routes in the OSPF route redistribution labs, the AD was the same every single time. But that's not the case with EIGRP. EIGRP internal routes, or regular ones that just have the D next to it, they of course have a default AD of 90. And an external route has a default AD of 170. So that might change things as far as router 2 goes, because routers 4 and 5, we don't really have to worry about those. That's why I didn't spend much time with them in the OSPF labs, because they just ran one protocol. It was router 2 we had to watch out for with suboptimal routing. Let's see what kind of problems, if anything, we have going on router 2. Okay. Now this is the total opposite, the polar opposite, or just the opposite of what we saw at this point in the OSPF lab. After route redistribution in the OSPF lab, 10110 was seen by router 2 as an OSPF route. And that's where we had a little bit of suboptimal routing coming in, because router 2 had, if it was sending packets to that loopback up on router 1, then the packets were going through the Ethernet to router 3, and then router 3 was sending them across the same cloud that router 2 could just go ahead and do directly. So why is this different? I know you know the answer to this. Why is this different? The reason is that administrative distance change. It's a huge change, because right now R2 is hearing about this network from two different sources. It's hearing about it from RIP via R1 10110/24. It's also hearing about it from router 3, but the AD is much higher. It's 170. So anytime a router hears about the same route and the same prefix length from two different sources, it's going to compare the administrative distance. That's our tiebreaker. That's why you don't see the EIGRP route in the routing table. Now let's go ahead, and we're going to do the same thing we did in the last lab, and see what happens when we close the serial interface down on router 2. That, of course, is going to cut our RIP updates off, and the only thing we'd still be getting is our EIGRP route. And you can see the RIP route's already gone, and the EIGRP routes have now entered the table. Again, with the AD of 170 with the next hop of 3113, and thankfully we can still ping that loopback up on router 1. So that's where the ADs come into play. It's a big difference from router 2's tables in the OSPF lab. Now let's go ahead, I'm going to go ahead and reopen that interface while we talk about this. We're going to do a little bit of administrative distance changing, not as much as we did with OSPF. So take a breath, it's okay. Let's go ahead and bring up, sorry about the ding there, trying to get back on those, router EIGRP 100, and let's look at our distance options here. Now we do have a set route administrative distance option, but what I really want to show you is the EIGRP option. Set distance for internal and external routes. So distance EIGRP, and now it's asking, do you want to change or what do you want the distance to be for internal routes? Because there's a slight gotcha with this command. Let's say that I want to change the AD of EIGRP external routes on this router to 119. So if I want to do that, I have to put in a value for the internal routes, even if that one is staying the same. I can't just say distance EIGRP external 119. So I'm going to keep that one at 90, and the next one is going to ask me for external routes. I'm going to set that one to 119, and there are no options with that. So don't see it there. Ah, there we go. What's going to happen, and the adjacencies came right back up. Using that distance command in EIGRP will make your adjacencies bounce. Well, hopefully they'll come right back up. They certainly should. If nothing else has changed, they will come back up. But that is certainly something to be aware of. And there's the route. Now this route is in the routing table instead of the RIP route. Why? Because its AD is lower. It's 119, and the change was successful. No problem at all. But the only thing you need to really keep in mind with that command, it's going to be obvious when you're on the live equipment, but on the exam it might not be as obvious if you're answering it in a multiple choice question. Internal distance comes before external in that distance EIGRP command, and you have to enter a value for each. You can't just enter it for one. So that is going to conclude our look at EIGRP route redistribution. We've seen what the routes look like once they're redistributed. We've seen the code. We know the default metric command. We know how to put the metric on the redistribute command. And now we know how to change the administrative distance of internal and external routes with that command. So with that, take a breather, and I'll see you on the next vid.